Hey guys, I want to go over some of the homework questions. This is number 4 from lesson 2. So I already wrote out the information that's given to us and what we're looking for. So the cone questions, I've said that in the past, are the more challenging ones because if you look at the formula, there are two variables in it. So if you differentiate it, there will be product rule. So you must know R, your dr, your H, and your dH if you're solving for the rate of change of the volume. And if you're sometimes not all of those four things will be given to you, so you will have to end up substituting either R for H or H for R. You'll determine the relationship and then substitute, and that's what we're going to be doing in this question. So here, if you look at this, it's saying the height is 30, means this height, I'll change the color actually, this height is 30, the diameter is 20. If you look at the diameter or the radius all along the cone, it will be different. It is not consistent, it keeps changing. Okay, that's one thing you want to know. And also, if you're talking about the water, the height will also change depending on how much water is in the cup. So those were the two things that's given to us. We found our radius. How? Because we know our diameter is 2r, so radius would be just half of diameter, which is 10. I am already given my rate, the volume, dv over dt, right? If you were confused, you look at your units. This is centimeter cube per second. The per second part tells me it's a rate, and volume is cubic, so this is my 2 pi over 3. I don't know, I want to find the rate of change of my height or the water level rising, which would be the height of the cone, when you have water up till 2, so or 2 centimeters. So that's basically it. Like, what would be the rate, at what rate is the height changing? That's what we want to find out. So now if you look at the formula, there is R and H, but I do not know if I did the product rule. Sorry about that. If I did the product rule, I need to know my dr. I don't know my dr. I know my R, but I don't know my dr. I cannot have two missings in one equation. So what I'm going to do is I'm going to find out the relationship between R and H. So I know, R over H is what? What's the ratio for R? 10 over 30. So let's solve for R. R is going to be 1 over 3 H, or H over 3, whatever you want to do. Now I'm going to take this relationship and substitute in here. So volume is equal to 1 over 3 pi. In place of R, I'm going to write 1 over 3 H square, right, times H. If I simplify this, I will get what? 1 over 27 pi H cube. Do we all agree? Because 1 cube is 1, H square is, 1 square is 1, H square is, H to the second power is H square, and 3 square is 9, 9 times 3 is 27. That's how I got that. And H squared times H gives me H cube. Now I want to take the derivative, so this would be dv dt. We are differentiating with respect to time, so please remember that. I'm going to bring the 3 in front, so this would be 3 over 27, which is 1/9 pi, and you go power down, right? Basic power rule. But remember your implicit differentiation, dh dt, and this is what I'm solving for, right? So I already know my dv dt is 2 pi over 3 equals 1/9 pi. My h, what is my h? Be careful, I'm not going to use the h 30. I'm going to be using the one that says 2 square dh dt, right? So now if I simplify this side would be 4 pi over 9 dh dt, and this is 2 pi over 3. So if I cross multiply this, right, this would be 9 times 2 pi over 4 pi times 3, which is dh dt. The pi's cancel out, 2 goes into 4 twice, 3 goes into 9 3 times, so I have 3 over 2, dHdt is 3 over 2, and this would be centimeters per second. Okay, so this is how you do it. I think the hard part was over here to determine